Hi, I'm following along with Paul McWhorter's Raspberry Pi lessons. We're on lesson 25, and our homework for today was to uh, combine our 1602 LCD with the DHT11 temperature humidity sensor and display the results on the LCD. Um, so I got that done, so I figure I'll go ahead and show you what the results look like. So, and my camera really doesn't work well with this, so I had to really dim down the resolution or whatever on it. But you can see I got the temperature and humidity, and we can change the Fahrenheit by just clicking a button. That was our homework. So that's what I got. So, oh, you want to know about the supersized digits there? Oh, yeah, maybe I should explain that. That's going to take us back in time a while. Let's make this a little smaller. So, way back in 2016, another of the internet people that I follow is Ralph Bacon, and he made a video about big digits on the LCD screen for Arduino. And I thought that was really cool and played around with it and forgot about it for several couple years. And then a couple years ago, I was making my custom or my custom greenhouse controller board that I've talked about in the past, and it actually uh, the I knew I wanted to use a character LCD, so I wanted to have the bigger digits in that, so I incorporated it into my controller on that. So the good thing is like I said, you can see these numbers from about 10, 15 feet away. Uh, Otherwise, to see these little numbers, you'd have to really come in there and get, probably a foot or 2 feet away from it. So when I'm walking by the controller, I can see what the temperature in the greenhouse is real easy. So it really came in handy. So that's I said that's pretty cool. So I actually knew Paul had this lesson coming up, so I started investigating the 1602 library, and I said, "Wow, it'd be cool if I could use the big digits with the Raspberry Pi." So I started looking at the library, and lo and behold, it doesn't have a method for using custom characters. That's how you get the big digits by the LCD 1602 displays have a way of adding custom characters. I'm gonna link to Ralph Bacon's video. He explains how you get them a lot better than I do, but you need a way to get custom characters into your LCD, and it they weren't available. So I said, "Oh, okay." Uh, so maybe I'll show you how it actually works on the Arduino first. So this is the Arduino, and Arduino's used the Liquid Crystal I2C library, and it has a method down here. Let's see, create character. So you can lcd.create character in Arduino to do your characters. So on Arduino, you have to add all this to your Arduino code to get the characters. There are a bunch of arrays, two deep arrays to get it, two layer arrays to get it, the characters, and then you got to have the same thing to create the uh, that was for your custom characters, and then this is how you combine those characters to make your digits. This actually only works for digits. You can there haven't there's some been some attempts to use it for big letters and other things, but they get really weird looking. So I only use this for the digits. I mean, and especially when you don't have that much room on your LCD, you really don't want to do that anyhow. So that's the thing. So when I was investigating this, I said, well, I wonder how much trouble it'd be to go to the data sheet for those displays. So I found the LCD module display data sheet. And after a lot of reading of the data sheets, I found the uh, commands that I had to pass to this to uh, add add the custom characters. I said, well, that sounds okay. So I took the 1602 library, and I actually added a method to it. And while I was at it, instead of having to have all this in our Python code, I said, well, it'd be just as easy to add all these custom characters and big number arrays to our right in the library. So I add those in the library, and came down here, and when you initialize the library by giving it your address and the one or whatever it is, then at the very bottom here, you can see I added my own. Uh, uh, this is the function that you need to do to give it the custom characters, and that's how you do that. And then I also add a new method to it. So I have a new method called big digits. Now you can't just go and display uh, integer, a big integer, or a floating point number. This only, I didn't want to take it that far. So this only actually, uh, you pass it what column you want it to start on and the digit that you want to display. So that's the two things that you're going to pass it from your Python code. So if you have like a 2-digit number, you're going to have to do the math in your code to separate the tens digit from the ones digit, and that what pretty cool. So I actually got this working, and it worked really well. So I actually put it on my GitHub page. So I actually have the library and an example code that you can download. So you can download the library and put it in there. It's got the BD, it's got LCD 1602, but BD for big digits. And so it's not same as so you can use both libraries in your folder at the same time. And then you could download this uh, example code that'll run. I probably won't go over that now. You can just see it running, but just a little readme here, just this part here, just telling you what I did and everything. So I'll link to this in my uh, notes on this. So let's see, where do I want to go to next? I guess I'll go to the code that's on the Raspberry Pi. Let's make this smaller. So the way we did this, like I said, we had to get the DHT, we needed time, we needed the GPIO libraries for the button as well as the DHT11. And like I say, I imported the 1602 BD as LCD, and initialized the LCD with the 27 and 1, just like that. One thing I did probably different than most people will do is I use my event detect on the GPIO to detect when a button is pressed, and this lets you do a callback, sends it off to any time. This is like a interrupt for the Raspberry Pi, and it sends you off to a new thread called button press. And this is a separate thread, so this is going to run immediately anytime you press the button. So you can put a delay down here in your while true, and it won't affect it. We're just setting a global variable called SC scale. It's just a Boolean variable for whether it's Fahrenheit or not. So if it's Celsius, it's 0. If it's or false, and if it's Fahrenheit, if you want Fahrenheit, it's going to be true or 1. So that's all that. And like I say, we use that down there to decide what to display on our thing. The rest of it's pretty self-explanatory from the DHT11 and the other threads that we did. So, like I said, we're DHT11. We're just getting our read, and if we get results, we're going to. I also just rounded them to 0 to integers. So to do that, you just put this round in there, and it'll round it to the nearest integer. And if I just made Celsius, TC, temperature Celsius, and TF for temperature Fahrenheit. For the Fahrenheit, you just do the math in here, which is Celsius times 9/5 plus 32. So that's what you had to do there. And then I also got your results for the humidity. That way, if you didn't get results, we still are going to update our display every half second. So we're doing that, and this is just a shorthand way of doing an if-else statement in Python. And so it's just if SC, if what we up there is the Boolean, if it's true, if it's 1, then we're going to make T equal to TF, else T is going to equal to TC. That's all that means. It's just a shorthand way of doing it. I like my shortcuts, and all my coding I do, and I know drives some people crazy, but it's a valid way of doing it. And once you know how it works, might not be very portable for other people. So these 4 lines here are what we need to do to make our big digits. So we know our temperature. I'm assuming our temperature is going to be between 0 and 99. I probably should have put a thing in here to keep it between 0 and 99 because it'll probably air out if you don't. But to get your tens digit, you just do an integer divide by 10. So if you got 20 and you just 27 and you divide it by 10, then you're going to get 2 in the integer. And since we're turning it, so you're going to get 2 in the 10 spot. And then you got this modulo operator here. You're doing the temperature, and you're dividing by 10 and taking the remainder of it as percent is gives you the remainder. So if we had that 27, the ones is this will be a 7. And then, like I said, all you do is this lcd.bigdigit, and it tells you that you want to start in column 0. So that's the very first column. And you want to put in the digit for tens. And then the same way, each of these characters takes up 3 columns, and then you want to space in between them. So we're going to 0, 1, and 2 for the number, and the space is 3. So then we want to start the second digit, the ones digit, on column 4. And it's going to take 4, 5, and 6. So then if you notice, I got the F or the C up there on the thing. So I did another shorthand. If it's Fahrenheit, it's going to put the F the scale is going to be F, and if it's that, then it's going to put the C. So we're putting that at column 7 and 0 for the top row. And then for the humidity, I already had, well, the humidity, I wanted to round that to a single digit as well, or the integer number as well. So we're just writing that at starting at column 8 on the second row, or number 1. And we're just saying RH and relative humidity equals that number, and then put a percent sign after it. And that's basically all we're doing. And then we're cleaning up and clearing our screen, and doing GPIO clean it and printing goodbye. I think somewhere in the comments or in the chat, somebody was saying, well, when you're using, of course, I'm using my Visual Studio Code, and somebody said, well, the keyboard interrupt doesn't work in on the Raspberry Pi. It works. The only thing is you got to put your cursor down here in your terminal before you hit that uh, Control C. Should be able to hit Control C now, and you see it went ahead and printed out the goodbye. If you don't put your cursor down here, and then the Control C doesn't work in here. So that's one downside to using Visual Studio Code. But anyhow, that's my question. And like I say, it blanked our screen, and we can start it up again. And we got 27, and we can change it over to Fahrenheit. So the big digits are kind of cool, and you guys are welcome. I'll link to the library, the BD library in there. So if anybody wants to try it out, you're welcome to try it out. Anyhow, that's my homework video for this week. Probably a little longer than normal, but I want to thank Paul for all he does, and kind of cool that we get to do all this together. Talk to you later.